So yesterday we pushed into the little bit of the small algebra portion of the course here with solving equations. So today we want to take that next step of solving more complex equations. To review just a little bit, we saw some equations that looked like this. Seven x plus 5 minus 2x equals 30. And we see here that the variable appears twice. But if we think of this equation as that balanced scale, both times, both the 7x and the negative 2x are on the same side of the scale. So we could just combine them. 7x, and remember the sign goes with the number after it. So 7x and negative 2x make 5x. We still have the plus 5 there, and it equals 30. Now we can start to take this apart to solve it. So we would subtract the 5. 5x equals 25. And divide by the 5. X equals 5. Well, another variant to that might look something like this. Seven x minus 4 equals 3x plus 28. Once again, we see that the variable appears twice. If we think of it as that balanced scale, however, this time we see that the variables, the 7x and the 3x, are on opposite sides. We cannot just push them together anymore because they're not together. They're not on the same side of the scale. We have to get rid of one of them. Typically, we'll get rid of the smaller one, which would be the 3x. So I'm going to subtract the 3x from both sides. So I have to subtract 3x from the left side as well. The only place I can take it away from is the 7x. 7x minus 3x is 4x. We still have the negative 4 there. On the right side, the 3x is gone, so we just have the 28. Now to solve this, I am going to add 4. So I have 4x left on the left side. On the right side, 28 plus 4 is 32. And my last step, to get rid of the 4, I divide by 4. X equals 32 divided by 4 is 8. And there was a final level of complication we ran into. That was parentheses. We had things like 4 times 3x minus 1 equals 56. Whenever we see parentheses, it should always scream at us to do something here first. And in an equation, we have two questions we have to ask. Is there anything we can do inside the equation? Well, here, nothing we can do in there. Can't combine the 3x or the negative 1. So the next step is then to do something to the equation. And that'll be the times 4. And this has to be what we call distributed. It has to multiply each piece in the equation. 4 times 3x is 12x. 4 times, remember now this is a negative 1. 4 times negative 1 is a negative 4. Equals, well, that's the end of the parentheses, so there's nothing more that needs to get multiplied by the 4. Equals 56 on the other side. And now we're ready to solve this. We'll add 4. 12x equals 60. And we'll divide by 12 to get x by itself. Get x equals 5. So we came up with, the steps of solving an equation, taking it apart. You just have to look at how it was put together and then reverse those steps to take it apart. But sometimes there's things we had to do before we solved. So to solve an equation, the first thing we had to do was combine anything that we can combine on each side. The second thing was to make sure the variable is on one side. Example up here, the variable was on each side. We had to get rid of one of them, so it was only on one side. So then once we've done those two things, then we can solve. Remember, solving, that's that process of taking it apart. Well, today we're going to move up into more difficult equations, more complex equations. We're going to start something like this. 8 times 2x minus 7 plus 5 equals 24. So here again, combine whatever we can combine on each side. Here we have parentheses on the left side. That means there's something we can do there in most cases. Nothing to do inside the parentheses. So we're going to multiply by the 8. 8 times 2x is 16x. 8 times negative 7 is a negative 56. 5 is outside the parentheses, so it does not get multiplied, but it is still there. The plus 51 equals, I said 29 and I wrote down 24 over here. This should have been 29, sorry. That should still be 29 over there. I just wrote it down wrong. It equals 29. Well, there's still more that we can combine on this left side. We have the negative 56 and positive 15. So I still have the 16x, negative 56 and positive 15. Well, from 0, I've got negative 56, and I said positive 15, negative 56 and positive 5. So we got negative 56. Positive 5 goes back this way. So that's going to leave us at a negative 51. That equals 29. Now we can go from there. Now we've combined everything we can combine on either side. And the variable is on only one side, so we can go ahead and solve it. We're going to add 51 to both sides. We get 16x equals 29 plus 51 is 80. And then we'll go ahead and divide by 16 to get x by itself. X equals 5. Well, there's other ways that this can be complicated. I can throw variables on both sides. Like this, 7 times 2x plus 5 minus 4x equals 5 times 6x minus 3 plus 4. So here, again, we go through those steps. Combine anything that we can combine on either side. So let's start on the left side here. On the left side, we have parentheses. Nothing we can do inside those parentheses. So we will do the multiplying by 7 here. 7 times 2x is 14x. 7 times 5 is 35. It's a positive 35, so I'm putting the plus in front of it. The negative 4x is not in the parentheses. It's outside the parentheses, so it does not get multiplied. That just sits there as a negative 4x. Now let's keep going on the left side here. There's more that we can combine. We can combine the 14x and the negative 4x. 14 and negative 4 make 10, so that is 10x. And we have the positive 35 is still there. Now there's nothing more we can combine on the left side. Let's go to the right side. On the right side, there's nothing to do in that parentheses. Let's multiply by the 5. 5 times 6x is 30x. 5 times negative 3 is a negative 15. Once again, the 4 is outside the parentheses, so it doesn't get multiplied, so that just stays a 4. There's still more we can combine. 30x is going to stay the same, but we have a negative 15 and a positive 4. That's a negative 11. Now we've combined everything we can combine on the right side. But the variable's on both sides. We have to get rid of one of the variables. We have 10x and 30x. The smaller one is the 10x, so I'm going to subtract 10x from both sides. That 10x is gone. We have 35 here. Equals 30x minus 10x is 20x. And we still have the minus 11, or negative 11. Now we've combined everything that we can combine. The variable is on one side. We can go ahead and solve. We're going to add 11 to both sides. 35 plus 11 is 46. So 46 equals 20x because the 11 is gone on the right side there. And the last step is to divide by 20 to get rid of the 20. We have x equals, now we have 46 over 20. If we divided that, we're going to get 2.3. That would be just fine to get 2.3 if we want it as a decimal. If we want it as a fraction, you recall we've said several times that division problems and fractions can be transferred back and forth. Instead of treating that as 46 divided by 20, let's just treat it as 46 20ths and reduce. First of all, 20 goes into 46 twice with 6 left over. That's 2 and 6 20ths. Well, both the 2 and 20 or the 6 and 20 can be divided by 2, giving us 3 over 10. And of course, the 2 for the whole number is still there. That's 2 and 3/10. 2.3 is also 2 and 3/10, just different ways of writing it. So if you want it as a decimal, that's fine. Or if you want it as a fraction, you just reduce it, turn the division into a fraction and reduce it. Problems like this tend to really trip people up. (19 minus 3x equals 4). This minus here, and actually let's just do this. 19 minus x equals 4. That minus in front of x, it's not really subtracting x, because x is not doing anything in this problem. Things are being done to x. If we were subtracting x, that means x is doing something to something else. What's really happening here is that's a -1 times x. And if we think of it that way, it becomes easier to work with. We subtract 19 from both sides, leaves us with just -1x on the left side, equals 4 minus 19 is a -15. And now to solve, I have to divide by -1 to get rid of the -1. X equals positive 15. Well, that makes sense. 19 minus 15 does equal 4. Well, the equivalent with our parentheses to this looks something like this. 2x minus parentheses 5x minus 1 equals 16. Look at this one. We see the parentheses, and there's nothing to do inside those parentheses. So we ask, well, what can we do to those parentheses? And at first glance, it looks like nothing. But just like we had the minus in front of the variable here, we have a minus in front of our parentheses here. And what we have to do to that is we have to turn that into -1 times those parentheses. So the 2x here is not going to change. That's just 2x. But we're going to distribute or multiply that parentheses by the -1. -1 times 5x is a -5x. -1 times -1 is a positive 1. Negative times a negative is a positive. The other side's still 16. Nothing's happened there yet. Now we can combine here. 2x and a -5x make a -3x. Plus 1 equals 16. Now we're ready to solve. We'll subtract 1. We have -3x equals 15. And we divide by the -3. X equals -5. So once again, the key there is, remember, when you see that negative, just like seeing the negative in front of the variable, you got to put in -1. When you see the negative in front of the parentheses, you also have to make that a -1 times the. So we can see this in a little bit more complex fashion in something like this. 2 times 5x minus 4 minus 3x plus 2 equals 4. So when we look at this, there's things to combine on the left side. There are two sets of parentheses. Order of operation says more than one thing at the same level, we go left to right. We'll start on the left side with this parenthesis. Nothing to do inside that parenthesis. We can't combine anything inside it. So we're going to go ahead and multiply by the 2. 2 times 5x is 10x. 2 times negative 4 is a negative 8. So we've combined, we've multiplied that set of parentheses. Next set of parentheses, there's nothing to combine inside of them again. So we're going to multiply by that negative, remember, is a negative 1, multiplying the parentheses. So negative 1 times 3x is a negative 3x. Negative 1 times 2 is a negative 2x. Or negative 2, sorry, just no x, it's negative 2. Right side hasn't changed, still just equals 4. But there's more we can combine on the left side. We have 10x, come on, and negative 3x makes 7x. Negative 8 and negative 2 makes negative 10. Of course, that still equals 4. So to keep solving here, we're going to add 10. 7x equals 14, and I'll divide by 7. X equals 2. So that's a lot of work for that simple result of x equals 2. But as long as you go step by step, they're not so bad. So let's jump ahead. Since it's just the two of us today, we'll jump ahead to a little bit more difficult example, and then we'll move on. We'll hit the big kahuna. Make sure you leave room in your notes and write small, because this one's a long one. 3 times 5x minus 1 minus 2 times 3x plus 4 equals 5 times 2x plus 7 plus 2 times x minus 3 plus 2. This looks nasty, and it kind of is, but it's not terrible as long as we follow our procedures and go step by step. First step is always combine everything we can on each side. Let's start on the left side. First set of parentheses, there's nothing to combine there, so we're going to multiply by the 3. 3 times 5x is 15x, and 3 times negative 1 is a negative 3. Second set of parentheses, again, nothing to combine there. We're going to multiply by, remember that's a negative 2. Negative 2 times 3x, negative 6x, and negative 2 times 4 is a negative 8. Now we're going to keep combining on that left side. 15x and negative 6x make 9x. Negative 3 and negative 8 make negative 11. That is all that we have to combine on that left side. Now we'll go over to the right side and see what we can do. Nothing to do inside that parentheses, so we'll multiply by 5. 5 times 2x, 10x. And 5 times 7 is 35. Our second set of parentheses, nothing to do inside there, so we're going to multiply by, that's plus, so that's a positive 2. Positive 2 times x is a positive 2x. Positive 2 times negative 3, a positive times a negative is a negative, so it's negative 6. This 2 is outside the parentheses, so it doesn't get multiplied, but it is still there, so there's a plus 2 out there. Now we combine 10x and 2x is 12x. 35 and negative 6 is 29. 29 and 2 makes 31, so plus 31. We've combined everything that we can combine on both sides. But the variable's still on both sides. We need to get it to one side. 9x and 12x, the smaller one is the 9x. So I'm going to get rid of that. It's positive, so I'm going to get rid of it by subtracting. I'll have to subtract 9x from the other side of my equation as well. Can only take it away from other x's, so I'll subtract it from the 12x. So on the left side, the 9x is gone. I just have negative 11 equals 12x minus 9x is 3x. I still have the positive 31. Now I'm ready to solve, so I'll subtract 31. Now we have negative 11 minus 31. I'm going to turn that into negative 11 plus a negative 31. So from 0, I've got negative 11, negative 31. They both go in the same direction. That's a negative 42. Equals, well, over here the 31's gone. We took it away, so it's just 3x. Finally, we divide by 3. Negative 42 divided by 3 is a negative 14. 3 is canceled out there, so that's just x. So x equals negative 14. That's what we get for that problem. Not the prettiest problem we've ever done, but again, as long as we go step by step, we'll get there. You can run into problems like this. Most of the equations we have solved so far have been two-step problems, where only two things have been done to x. It's been multiplied by something, and then another number's been added or subtracted to it. This is a three-step problem. What was done to x here, it was multiplied by 3, the 7 was added to it, and then the whole works was divided by 4. So to take it apart, we start out by getting rid of the dividing by 4 by multiplying by 4. That takes that piece away. We multiply the other side of the equation by 4 as well. So 3x plus 7 is all that's left on the left side. 7 times 4 is 28. So 3x plus 7 equals 28. Now we've combined everything we can combine. Well, there's nothing to combine. The variables on one side. We took away the dividing by 4. We'll take away the adding 7 by subtracting 7. 3x equals 28 minus 7 is 21. And we take away the multiplying by 3 by dividing by 3. X equals 7. As always, any of these equations, we can go back and replace the variable with the number we got. If I put 7 in there, 3 times 7 is 21. 21 plus 7 is 28. 28 divided by 4 is 7. So it makes it true. So we can always go back and double check our answers that way. So there the fraction came into play as just an extra step that had been done to build our equation. But sometimes the fractions can be the numbers within the equation. We might have 3/4 x minus 2 1/2 equals 3 5/8. This equation, solving it, is no different than having 2x minus 5 equals 11. If I were going to solve this, the first thing I would do is add 5 to both sides. Get 2x equals 16. Over here, even though it's fractions, that's exactly what I'm going to do, is I'm going to add the 2 1/2 to both sides. The 2 1/2 is gone. I have 3/4 x is all that's left on the left side. On the right side, I have to do the work with the fractions. I have to add 3 5/8 plus 2 1/2. Well, the 3 5/8 I'm going to leave the same. 2 1/2, I'm going to make that 2 4/8. 5/8 plus 4/8 is 9/8, which is 1 1/8. So I'll keep the 1/8, carry the 1. 1, 3, and 2 is 6. That's 6 1/8. Right now I have 3/4 x equals 6 1/8. And I finish that off by dividing by the 3/4. Just like over here, I would have just divided by 2. Here I divide by 3/4. So the 3/4 is gone. I have x equals. Now I do have to go through the effort of combining 6 1/8 divided by 3/4. So 6 1/8 has to be made into an improper fraction. 6 times 8 is 48, plus 1 is 49/8. Instead of dividing by 3/4, we're going to multiply by its reciprocal, so times 4 over 3. I can cross cancel here. 8 and 4 both divide by 4, so this will be 1 and 2. 49 times 1 is 49. 2 times 3 is 6. 6 goes into 49 8 times with 1 left over, so that is 8 1/6. So x is 8 1/6. So really the only difference in this equation is we had to do all of our work with our fractions instead of just having whole numbers. And it's a lot more difficult because whole numbers, most of those calculations we can do in our head. Fractions we can't. We have to actually work it out. generally we go off to the side of the paper, do the calculation, and bring the answer back in. Or if you have your fraction calculator and you're good with it, feel free to use it. That's what it's there for. Now, there's an alternate way we could have solved that. Three and 5/8, I believe is what it was. So 3/4 x minus 2.5 equals 3 and 5/8. The alternative way I could have approached that is I could have eliminated the fractions. It is called using a least common denominator. Now, the least common denominator is what we use for adding and subtracting fractions. We use the same thing here to get rid of the fractions, make the fractions disappear. So we have denominators of 4, 2, and 8. The smallest number that all of those will go into is actually the 8. 4 goes into 8 and 2 goes into 8. So 8 is our least common denominator. Once we have that least common denominator, we can multiply the whole equation by that least common denominator. 8 times 3/4 x, we're going to go 8 over 1 times 3. We make that 3x over 4, because technically that's an x over 1, so 3/4 times x is 3x over 4. 8 times 3x is 24x. 1 times 4 is 4. And we can divide that out. 24x divided by 4 is just 6x. 8 times negative 2.5. If you do that math out, you end up getting a negative 20. Equals 8 times 3 and 5/8. Well, 3 and 5/8. First, the 8 over 1 into a fraction is 8 over 1. 3 times 8 is 24, plus 5 is 29 eighths. The 8's cancel out. That's just a 29 over 1, or just 29. And we see that we got this equation where all the fractions are gone. The fractions have disappeared. And we can solve. We'll add 20. 6x equals 29 plus 20 is 49. And we divide by 6. X equals, well, here's another case. Rather than dividing that out and getting 8.166666666, treat it as a fraction and reduce it. 49 over 6 reduces to 8 1/6. Exact same answer we had up here. Now, if you're not terrible at working with fractions, or if you can use the fraction calculator, I would say just doing the operations, solving the equation using the fraction operations is probably simpler than trying to multiply by this least common denominator. However, we will encounter some equations where we have no choice. For example, we might have 4x plus 3 over 3 minus 2x minus 3 over 9 equals 6x plus 4 over 6 plus x. Well, looking at this, it looks like a mess. And it kind of is. We will, once again, use that least common denominator, try to eliminate one of the fractions. Right now we have denominators of 6, 9, and 3. Well, 3 goes into either 6 or 9, so we don't have to worry about the 3. It'll be good if we can get 6 and 9. Well, for 6 and 9, it looks like our least common denominator would be 18. 6 goes into 18, and 9 goes into 18. So that means I'm going to multiply this whole equation by 18. Now, if I have 18 times 4x plus 3 over 3, two things have to happen. I'm going to put my 18 over 1, so it's actually a fraction. And that numerator has to be put in parentheses. 4x plus 3 is in parentheses. So when I multiply, I've got 18 times 4x, that is 72x, and 18 times 3, which is 54, 1 times 3 is 3. Now I can divide that out. 72x divided by 3 is 24x. 54 divided by 3 is 18. It's a positive 18, so I'm going to put plus 18 there. That was the 18 times the 4x plus 3 over 3. 18 times our negative 2x minus 3 over 9 is a little bit trickier because this minus in front. Remember, we treat that as a negative 1 times whatever comes after it. So I'm going to put that as an 18 over 1 times negative 1 times 2x minus 3 over 9. Now recall, we're going to put this 2x minus 3 in parentheses. That negative 1 I'm going to put over 1 as well. So if I can combine the 18 and negative 1, that's just a negative 18. So I'm going to have negative 18 times 2x is a negative 36x. Negative 18 times negative 3 is a positive 54. On bottom, 1 times 1 times 9 is just 9. But I do have negative 36x divided by 9 is a negative 4x. 54 divided by 9 is a positive 6. Well, now we still have to multiply. What happened there? Drag some things I didn't mean to drag there. Get rid of that. Now we still have to multiply the 18 times the right side of the equation. So 18 over 1 times 6x plus 4 over 6. I'm just going to put it in parentheses right away. 18 times 6x. 18 times 6 is 108x. 18 times 4 is 72. 1 times 6 is 6. 108 divided by 6 is 18. Yes, 18x. 72 divided by 6 is 12. And last we have the 18 times just the x there, so that's going to be a positive 18x. So we've eliminated all the fractions here. Now that's a lot of work. If you struggle with algebra, that might not be the easiest way to approach this equation. I have things to combine on the left side. I have 24x and negative 4x makes 20x. 18 and 6 make 24. On the right side, I have 18x and 18x is 36x. And I have the 12. One more to combine, but I have the variables on both sides yet, so I have to get rid of one. 20x is smaller than 36x, so I'm going to get rid of the 20x. I'm going to subtract 20x from both sides. So it's gone on the left. We just have 24 on the left side. 36x minus 20x is 16x. And I still have the 12. Now I can solve. I'll start by subtracting 12. 24 minus 12 is 12. The 12 is gone on the right side, so we just have 16x there. And finally, I'll divide by 16. So the 16 is gone on the right side, we just have x. 12 divided by 16, once again, we'll just treat that as a fraction and reduce it. Both those numbers divide by 4, giving me 3/4. X equals 3/4. That's getting pretty ugly. I won't be that mean to you on a test or a quiz, but it's something that's good to know how to do. So for right now, and we will practice this stuff more on Monday, don't worry, we'll have more time with it. But for right now, your homework, page 253, exercise 6.3, 1 through 59, the odds. And page 258, exercise 6.4, 1 through 25, the odds. So we'll let you have the rest of the class here to start on homework if you want. I'll be on the network for a while if you have any questions. Otherwise,